Hello students. So let's continue with the problems. So in the 10th question, two poles of equal heights are standing opposite to each other on either side of the road, which is 80-meter wide. From a point between them on the road, okay, the angle of elevation of the top of the poles are 60° and 30° respectively. Find the height of the poles and the distance of the point from the pole. Okay, let's say we have got a road like this. Okay, and there is a pole here. Okay, there is a pole like this, and let's say there is another. I'm sorry. Let's take it like this. Let's say there is another pole like this. Okay, these are the two poles. Okay, let's say this pole is AB, and let's say this pole is CD, and the distance between the road is given as 80 meter. Now somewhere in between, somewhere, okay, from this point, let's say from this point, let's take it some point as P. I'm sorry, from the point P we are observing both the top of the poles. Okay, and one angle is found to be 30 degrees. If I take this to be 30 degree, the other one will be 60 degree. Okay, now what we have to find is we have to find the height of both the poles. Both are equal. We have to find AB and CD. If you find AB, it will be equal to CD, and we have to find the distance BP and CD. Okay, this is the figure. Let's redraw this. Okay, let's just focus on this triangle part. Okay, so as you know, there are two poles. One, let's take it as AB. Okay, let's take this pole as AB. Okay, and there is another pole CD exactly opposite to this pole CD. Okay, and BD is the distance between the two poles. Okay, that is equal to the width of the road. Okay, the width of the road is 80 meters. The width of the road is 80 meters. Okay, now somewhere in between, let's say at this point. Okay, now from this point we are watching the top of both the poles. Okay, we are watching top of both the poles. Now from here, okay, let's say this angle of elevation is 30 degrees, and let's say this angle of elevation is 60 degrees. Okay, let H be the height of the poles. Okay, if AB is H, CD will also become H because both are equal. Okay, let's assume that the distance between B and P is X. Let's assume this distance is X. Therefore, PD will become the total 80 minus X, isn't it? So this becomes X, 80 minus X. Okay, so here AB and CD are the poles. Okay, now again we have to search for the right angle triangle. Okay, here this is 90 degree and here this is 90 degree. Again we have got two right angle triangles. One is ABP, another one is CDP. Now what we are going to do is, in both the right angle triangles, we are going to find AB and CD because the AB and CD are equal, right? So in triangle ABP, let's find AB, and in triangle CDP, let's find CD. Let's equate it because both are equal. AB and CD are equal according to the question. So let's equate it, we'll get the answer. Okay, so let's take, let H be the height of the poles. Let H be the height of the poles. Okay, let H be the height of the poles. So now let's take triangle ABP. In triangle ABP, again we are going to make use of tan itself. Okay, tan, the angle is 60 degree. So opposite to 60 degree is AB, right? So the opposite side, this is the opposite side, and this becomes the adjacent. Okay, the other one is in this triangle, this becomes the opposite side, and PD becomes the adjacent. So tan 60 is opposite by adjacent. Opposite is AB, adjacent is BP. So tan 60 value is √3, AB value is H, BP value is X. Therefore, if you cross multiply, √3x is equal to H, or H is equal to √3x. Let's take this as equation 1. Now what we'll do is, let's take the other triangle and find the value of CD, that is H. Okay, so in triangle here B is 90 degree, isn't it? So in triangle CDP, angle D is 90 degree. Again, we are going to make use of tan itself, but the angle is 30 degree. Tan is opposite by adjacent. Opposite is CD. Adjacent is PD. Okay, tan 30 is 1 by root 3 and CD is H and PD is 80 minus X. We need H, so let's send this 80 minus X to the other side. So it becomes 1 by root 3 into 80 minus X. Okay, that is equal to H. 1 into anything is same thing. So 80 minus X by root 3 is equal to H, or you can write H as 80 minus X by, let me rewrite it, 80 minus X by root 3, equation 2. So from equation 1 and 2, we can equate it, isn't it? From 1 and 2, RHS root 3x is equal to 80 minus x by root 3. Let's cross multiply. Root 3x into root 3 is equal to 1 into 80 minus x. 1 into anything is same thing. So root 3 into root 3, root 3x into root 3, root 3 into root 3 is root 3 square, which becomes 3x as it is. So 3x is equal to 80 minus x. Let's transpose minus x to the other side. So 3x minus x, if it comes, it will become plus x. That is equal to 80. 3x plus x is 4x. 4x is equal to 80. Therefore, x is 80 by 4. 80 by 4 is 20. Okay. Therefore, the value of x is 20 meters. That is distance between B and P is 20 meters. Okay, which implies BP is equal to 20 meters and PD is equal to 80 minus 20, 60 meters. But we had to actually find the height of the tower. So height of the folds. From equation 1, H is equal to root 3x. We know the value of x as 20. So root 3 into 20 is 20 root 3. That's the height of both the poles. Okay. So again, the same concept. Here we had two right angle triangle in which two sides were not common, but two sides were equal. So we found those equal sides and we equated it. We got the answer. So let's get into the next question. Okay. In the next question, they have already given the figure, but let's analyze it. Okay. A TV tower stands vertically on the bank of a canal. So AB is the tower, as you can see from the figure. From a point on the other bank directly opposite to the tower, that is from C, the angle of elevation of the top of the tower is 60 degree. Okay. From another point 20 meter away from this point, okay. See, 20 meter away from this point, I can take it in any direction. I can take it in this direction, or I can take 20 meter in this direction or in this direction. I can take 20 meter in any direction. But what they have done is they have taken along the straight line. Okay. That is at D. Okay. They've taken a straight line, a 20 meter like this. Okay. So D is the another point. From that point, the angle of elevation is found to be 30 degrees. Now, what we have to find is the width of the river and the height of the width of the canal and the height of the tower. Height of the tower in the sense we have to find the AB, and CB is the width of the canal, isn't it? Because C is the opposite. C is the point on the bank of the river, the opposite bank of the river. See, this is one side of the river where B is there. The other point is C. So the width of the river is CB. So let's assume the width of the river to be X. Let's say the width of the river is X, and let's say the height of the tower is H. Let's write that. Let H be the height of the tower. Let H be the height of the tower, and let X be the width. Let X be the width of the canal. Okay. Now again, the same concept. At B you will have 90 degree. Okay. So again, there are two right angle triangle. One is ABC. Okay. As you can see from the figure itself, one is ABC. Okay. A, B, C. Here the angle is 60 degree. This is obviously 90 degrees, and AB we have taken it as H, and CB we have taken it as X. So opposite to 60 degree is opposite side, and this is hypotenuse, and this is adjacent. And there is also another right angle triangle. Okay. that is DAB, the other right angle triangle. Okay, DAB. Here it is 90 degree. This angle is 30 degree. Okay, in between we have got C somewhere here. So this is X and this is 20 meters from the question. And AB value we have taken it as H. Okay. If you observe in both the figures, in both the right angle triangle, which is the common side, very clearly AB is the common side. So we are going to find AB, that is H is the common, right? So the value of AB is H. So in both the triangle, H is common. So we're going to find H in both the triangle and equate it. Okay. That is, let's take the triangle, smaller triangle ABC. Okay. Where B is 90 degree. Again, we are going to make use of tan itself. Tan 60 degree, opposite by adjacent. Opposite is AB, adjacent is CB. Tan 60 is root 3, AB is H, CB is X. So cross multiply, you get H as root 3X. Okay, let's take it as equation 1. Let's take the other triangle. In triangle ADB, B is 90 degree. Again, make use of tan itself. Tan 30, very clearly opposite is AB, adjacent is DB. Tan 30 is 1 by root 3 and AB is H, DB is 20 plus X, isn't it? So the total length will become 20 plus X. Okay, so cross multiplied or send this 20 plus X to the other side. So 1 by root 3 into 20 plus X is equal to H. See, remember I'm putting a bracket because there are two terms. So 1 into 20 plus X is 20 plus X. 20 plus X by root 3 is equal to H, or the other way, H is equal to 20 plus X by root 3. Equation 2. From 1 and 2, we can equate it, isn't it? From 1 and 2, LHS are same. Therefore, RHS is equal to. So what is the RHS here? Root 3X is equal to 20 plus X by root 3. Cross multiply. So root 3x, it becomes root 3x into root 3 is equal to 20 plus x. Root 3x into root 3. Root 3 into root 3 is root 3 whole square. Root 3 whole square, square and root gets cancelled. So we'll be left with 3. So 3x is equal to 20 plus x. Send the x the other side. 3x minus x is equal to 20. Therefore, 2x is equal to 20, which implies x is equal to 10. So the width of the canal is 10 meter. Now from equation 1, H was equal to root 3x. X is 10. Therefore, H will become 10 root 3 meters. That's the height of the tower. So in most of the problem, we are using the same logic. That is, if two triangles are there and one, if a side is common, we are going to find that and equate it. Okay. So let's get into the next question. So as you can see in the next question, from the top of a 7-meter high building, the angle of elevation of the top of a cable tower is 60 degree and the angle of depression of its foot is 45 degree. Determine the height of the tower. So what we have got is a building whose height is 7 meters. Let's say this is the building. Okay. AB is the building which is 7 meter high. From the top of the building, remember from the top of the building, we are observing the top of a cable tower. Obviously, the tower must be bigger, lengthier than the building, isn't it? Because from the top of the tower, we are observing the top of the cable. Okay, and they've mentioned it as the angle of elevation. Okay, so obviously the tower must be bigger. So CD is the tower. Okay, now from here we are observing the top of the tower. So let me draw it properly. We are observing the top of the tower. So always we have to draw the horizontal line of sight. So this will be the horizontal line of sight, isn't it? So let's also draw that, because only when we draw the horizontal line of sight we can guess the angle of elevation. So this is the angle of elevation. How much it is? 60 degree. And from the same point we are observing the foot of the tower. The foot of the tower is D. That is, from A we are observing the point D. Okay. Now let's take this point as AE. AE is the horizontal line of sight, and this is the new line. AD is the new line of sight. So this angle is 45 degrees. Okay. Let's join B and D. Okay. Now, what we have to find is we have to find the height of the tower. CD is the tower, right? CD is tower and AB is the building. AB is building. Okay. So very clearly at angle at B the angle is 90 degree, and at angle D, at D the angle is 90 degree. So using the rectangle property, this will also be 90, isn't it? And this will also be 90, linear pair concept, and here the complete angle is 90 degree because AE will be parallel to the ground. Remember, because it's an horizontal line of sight. Okay. Now here there are many right angle triangle. Okay. But we'll be taking only few. Okay, see, ABD is a right angle triangle, AED is a right angle triangle, AEC is a right angle triangle. There are many right angle triangles here. Okay, now if you observe the quadrilateral AEBD, all the four angles are 90 degree. Therefore, it's a rectangle, isn't it? So let me write that. In quadrilateral ABDE, all angles are equal to 90 degree. All angles are equal to 90 degree, which implies ABDE is a rectangle, which implies it's a rectangle. If it's a rectangle, then we can say the opposite sides are equal, isn't it? So which implies AB will be actually equal to DE, isn't it? AB will be actually equal to DE. Okay. So AB value is 7. So DE value will also become 7 meters. So this value, we got the value of this. Let me write it in a different color because we have got that. It was not given in the question. So this is 7 meter. That's what we have got. Okay. Now to find the height of the tower, CD is the tower, right? If you know this value CE, if you add with 7, it is done. The problem is done. So we have to know the value of CE. Now if you observe, AC is a right angle triangle. Okay. AC is a right angle triangle. In this right angle triangle, we are supposed to find the opposite side. C is the opposite side. Okay. Any one side must be given. Okay. They have not given the value of AC. They have not given the value of AE. So if any one thing is given, easily you can find the value of opposite. That is, if adjacent, or see, in this triangle, this becomes the hypotenuse and this is the opposite and this is the adjacent. Okay. If the hypotenuse is given, opposite can be easily found. If adjacent is given, opposite can be easily found, but they have not given anything. So what we are going to do is we're going to take the triangle AED. Okay. In that triangle, see, this is the angle. So therefore, this becomes the opposite and this is the adjacent and this is the hypotenuse. Okay. So they have given the value of opposite. So easily we can find adjacent. Okay. So what we are going to do is we're going to take the triangle AED first. In triangle AED, angle E is equal to 90 degrees. Now, let's make use of tan because opposite is given. Tan 45. Opposite is ED, adjacent is AE. Okay, tan 45 is 1. ED value is 7. That will be AD by AE. So cross multiply, you will get the value of AE, which is 7 meter. Now, since you got the value of AE, which is adjacent side for the triangle ACE, isn't it? In triangle ACE, AE is the adjacent side. In triangle AEC, E is 90 degree. Now you know the adjacent side, you can find the opposite side easily. Again, we're going to make use of tan. Now the angle is 60. Tan 60 is opposite by adjacent. Opposite is CE, adjacent is AE. Tan 60 is root 3. CE value, we have to find it. AE value, just now we got it as 7. Therefore, cross multiply, we'll get CE as 7 root 3 meters. Okay. Now what we have to find is height of the tower, isn't it? The height of the tower, the total height of the tower. How do you get? If you add CE and ED, you will get the answer. What is the value of CE? 7 root 3. What is the value of ED? 7. So we can take 7 as common. So we'll be left with root 3 plus 1 meter. I'm sorry, root 3 plus 1 meter. That's the height of the tower. Okay. Here, this problem seems to be a bit different, but anyhow, it is a very, very easy problem. Okay. And if I want to give you as a hint, you can just take those two right angle triangle. Okay. You can also apply the same logic what we applied in the previous problems. you have to take those two right angle triangles which have got the angles in them. Okay, so that will be AED and ACE, isn't it? Take these two triangles. Okay, the one which I'm shading above and below. Take these two triangles. AE is the common side. Okay, so in triangle ACE, find AE. In triangle AED, find AE. Equated, you'll get the answer. Okay, you can also do it like that. Okay, you have to take those two triangles, right angle triangles, in which the angles are given. Okay, so you can also do it like that. Okay, let's get into the next question. As observed from the top of a 75-meter high lighthouse from the sea level, the angle of depression of two ships are 30 degrees and 45 degrees. If one ship is exactly behind the other on the same side of the lighthouse, find the distance between the two ships. Okay. So initially what we have got is a lighthouse. Okay, let's say this straight line represents the lighthouse. Okay, let's say AB is the lighthouse. And from the top of the lighthouse, we are observing two ships which are on the same side. If you read the question, they have clearly given that there are two ships. Let's say C is one ship and D is another ship. Both the ships are on the same side of the lighthouse. And the height of the lighthouse is given as 75 meters. Okay. So let's join it. Okay. Initially, first we have to draw, since the person is at the top of the lighthouse, the horizontal line of sight will be like this, isn't it? So this will be the, let's take to be AE. AE is the horizontal line of sight. Okay. Now he is observing the first. Okay. Now there are two ships. The angle of depression is this angle and this angle. Obviously, the smaller one will be 30 degrees and the bigger one will be 45 degrees. Okay, using the alternate angle concept, because the horizontal line of sight will be parallel to the ground. Here it is parallel to the sea level. Okay, so using the alternate angle concept, that is Z shape. Okay, if you observe, this angle, okay, is alternate to this angle. So if this is 45 degree, this will also become 45. And if this is 30 degree, you will get 30 degrees here. That is using the alternate angle concept. And this will be perpendicular to the sea level or the ground. Okay. So it's very clear. As you can see, you can find the Z shape here. Okay. And the bigger Z shape here. That's what I have done. Again, here there are two triangles. See, actually what we have to find is the distance between the ships. That is between C and D, whatever the distance, we have to find it. Let's take it as X. Okay. X is the value that we have to find. Okay. So again, there are two right angle triangles. One is ABC, other one is ABD. Let me draw that separately. Okay. One triangle is ABC. Okay. A, B, C. Here they have already given the value of AB as 75 meters. Okay. And here it is 45 degrees. Okay. And there is another triangle ABD. Okay, the other right angle triangle is ABD. So here it is 90 degree and here the angle is 30 degree and this is 75 meters. So very clearly this is opposite and this is hypotenuse and this is adjacent. Again, this is opposite and this is hypotenuse and this is adjacent. Again, we are going to use the same logic. In both the triangles, AB value is given. Okay. So, I mean, AB is the common side. So, let's find AB. Okay. So, directly we'll get the answer. So, in triangle, let's take the first triangle ABC. So, angle B is 90 degree. Let's make use of tan itself. Okay. Tan. What is the angle? 45. Tan 45 is equal to AB by BC. Okay. Tan 45 is 1. AB is 75. BC as it is cross multiply, you will get the value of BC here. Okay, 75 meters. Okay, let's take it as equation 1 or let's just continue as it is in triangle. Let me do it here itself. Let's do it here itself. In triangle, the other triangle, in triangle ABD, again B is 90 degree, again using tan tan, how much it is? Tan 30 degrees. Again, opposite by adjacent. Opposite is AB, adjacent is BD. Okay. Tan 30 is 1 by root 3. AB is 75. Now BD value. See, in between you got somewhere here you got C, isn't it? BD is actually BC plus CD, isn't it? From the figure, BC plus CD. Now 1 by root 3 as it is, 75 as it is. Anyhow, we found the value of BC, right? Let's use it. 75 plus and CD value is X. Now let's cross multiply directly here. We are going to get it. Okay. So if you cross multiply 75x into 1 is 75 plus x. Sorry, 75 plus x into 1 is 75 plus x. Root 3 into 75 is 75 root 3. Okay, we need x. So 75 root 3. Send that 75 to the other side, it will become minus 75. So what you can do is you can take 75 as common. So you'll be left with root 3 minus 1. Therefore, the x, that is the distance between the ships. Okay, that is equal to 75 into root 3 minus 1 meters. Okay. I hope you have understood. Again, in more as like all the problems here, we had two right angle triangles. One side was common. Okay, AB was common. Here we didn't find AB and equated, but while finding using this logic, we got the value of BC. That value of BC we used it in the other triangle. Okay, and directly we got the value of X. That is the distance between two ships. Okay, students, we'll continue the remaining problem in the next video. Thank you, students.